Hello and welcome back to the third part of the tutorial series in which we will be creating our in-game clock. So in the last video we implemented the timer, most of the time manager, and just the data of our time state. In this video we will be adding the increasing methods and decreasing methods for our time, as well as a time converter, because currently we have no way of converting our total time to our time state and vice versa. So we will need a helper function or a helper class for that. So yeah, we just have our time state to int and int to time state methods that return the values they should, in this case the int, in this case time state. And we also need a getFactor method, which just returns the amount of minutes that every type has. So of course an hour has 60 minutes, a day has 24 times 60, and so on. And we will just use an enum for that. But first of all, let's fix a few things. I named this here the internal time wrong. It should not be timer, because we have a timer here. That's just our time state. And we forgot to add a property here. So let's add that. Then we also need a public const of type int, and this will be the days per month. And it will be equal to 30 in my case. With that out of the way, let's create a public void increase time by minutes, passing in the amount of minutes, as well as a decrease time by minutes. And in here we will set total time plus equal to our minutes. And in here, total time minus equals minutes. And of course we don't want to go below 0. So if our total time will be less than 0, we just want to set our total time back to the initial value by increasing it by minutes, just like so. We can now test that out. Internal time, internal time, increase time by minutes, 1. So every second our time should increase. And it does. Now let's check if it also decreases. Let's set it to 100. Decrease time by minutes. Let's hit play. And this works as well. Let's just set it to 4 to see what happens. And if it's at 0, it won't go below it, because every time it reaches, in this case, right here, -1. So 0 minus 1, so -1 is less than 0. So we add 1 and we are at 0 again. Now we need our time converter script. it will be a static class. And we will first add our enum with our factor type values. So we have our year, month, day, hour, and minute. And we also have a private static getFactor method that returns an integer. And it takes the factor type as a parameter. We will create a switch in here with the type, and by default we return -10. This will just show us that something is clearly wrong, because normally we don't want to anything else to happen except for in these cases. So for the minutes, let's just return 1. In here, return 60. Return 60 times 24. And the list goes on. And for the last one, we need system.enum.get values type of our TimeState .months, and we need the length of that. And what this does is it gets our enum values. So in here we have our spring, summer, autumn, winter values, and it just gets that, stores it in a list, and we can then just get the length of the list, which is in this case 4, and this gives us the amount of months we have per year. This looks okay, but as you can see, like, let's say we wanted to change the hours we have per day, we would have to change it here, here, and here. So a cleaner way would be to just call the previous factor, in this case, for example, minute. And in here we have 24 times our hour value, and so on. So let's do that. We have our get factor, 24 times will be replaced by TimeState days per month. And in here, just this part. This will be day, and this will be month, like so. Now we can close that up. And we need a public static int TimeState to int method that takes in our TimeState. First of all, we of course need our time and set it to 0. And then we increase our time accordingly. So state dot minute times get factor minute. Let's just copy that a few times. We need the hour, the day, the month, and the year. And in the end, we return our time. We have hour, the vector type day, month, and year. Now this is highlighted in red because state.month is an enum value and get vector returns an integer. So we just have to cast that as an int. And this will be fine now. So we have our time state to int. What we can actually do is in our time manager, in awake, we can set internal time. We will need a public void update state for that. It takes in a time state. And we will set this dot minute equal to state dot minute. Same for hour, day, month, and year. Like so. And then we can set total time is equal to TimeConverter dot TimeState to int. And we need a state for that. So we can set internal time equal to a new time state. Actually, we could have just in here do the exact same thing. So let's just copy that. Pass in this as an argument. And we should be good to go. So this will be a new time state, and we will just set up a few values. So we have year 2, we have summer, the 4th day, 12 o'clock, and I don't know, something like that. Now these values should change and the total time as well. And indeed it does. But right now, first of all, it still decreases our time. We don't want that. And as you can see, our minute down here doesn't change with our total time. So we need another method in here. Let's first set that to increase time by minutes. So that one is fixed. And now we add our public static int, not an int, time state, int to time state, which takes in our time value. Let's for now just return 0. Not 0, but a new time state. Time state is equal to a new time state. That's weird. Whatever. Return state. And now we need a another method that returns an int. Let's just have a look at my notes here. Right. Public static int get division result, which takes in a reference to our time as well as a divisor. And this will calculate some things that I will explain in just a moment. So let's say we pass in some time. We have, for example, let's get our calculator here. We have 60 times 24, 1440 minutes a day. So let's say we would have 1500 as the time. So right here, this is equal to R, our result. And we divide that by, let's say, our year value at first. So some really big number. I don't care really what it is. But what this will return is 0, because this value is less than this value. This will be 0, and therefore we will decrease our time by 0. And because this is 0 and it, remember, we will pass in here the year in this case. This means that we have not reached any year and we are basically at the 0th year. Now let's say we arrived at our day value, which is 1440. This will be 1 and therefore return 1, but we also decrease our time by that value. So the next time we will have, actually that's a little bit of a bad example. Let's change that to 1, just so we have it. And we divide that by 60, because remember, this was the amount of minutes we have per day. This is per hour. And then we have per minute. That's what will basically happen every time we call this method. So we can say time is equal to, we don't actually need that. That's wrong. We need int year is equal to get division result and pass in the time as a reference, as well as a get factor type year. And we can copy that, set the month, the day, hour, and minute, every time passing in the time as a reference. Let's just clean that up a little bit. Like so. And this will be month, day, hour, and minute. And at the end, in here we can just pass in year, month, day, hour, and minute. Now, of course, month again is just an integer, so we have to cast that as a TimeState dot months enum value. And with that done, all we have left to do is, after we increase our time by the minutes, let's just remove that because we don't need it. We want to get our new state. So we update the state like so. And that's all we have to do. Actually, no, that's not all we have to do. This will just return the value we have. We have to call TimeConverter dot int to TimeState with our total time. And that's all we have to do. If we now hit play, we should see our hour and minute update right away. And indeed it does, but there are a few problems. I forgot to remove that. Without it, we can't really test that the values are correct. And yep, the values are correct, indeed. Now there are a few problems with this. First, our day and our year are incorrect, or at least for me, they are incorrect because there is no 0th day and we are not in the 0th year, so to speak. We want to be in the first year and on the first day when we start our time at 0. And so let's change that. And the easiest thing to do here is just in our assignments here, for the year, we have to add +1 as well as for the day. And here we have to subtract 1. So -1. Actually, it's exactly the opposite. Exactly the opposite. In here we have -1. And in here we have +1. Let's have a look. We get our division result. So we have 0 for the year if we are, let's say, in the first minute. And we add to that +1 and for the day as well. And in here we get our value and decrease it by 1, but that's actually wrong because time is our total time in minutes, so this will just subtract 1 minute. So what we have to do instead is get our state dot day and subtract 1 from that and then multiply it by our factor type. And we can do exactly the same for the year. And hopefully we can see we are on the first day in the first year. And if we were to increase that, it updates accordingly. Great. So for now, we don't have a way to do exactly the opposite because we don't want to change our total time. We actually want to change our year and so on. But if we were to change them now, they just return to the value that gets set through the total time. We will not be able to change this behavior until we implement a custom property draw. But for the next video, we will actually implement the UI so we can increment and decrease the time through buttons, as well as see the time as a text and as a watch. See you then.